Hi, my name is Vidhan Parsala and today I'm going to teach you arithmetic pipeline. So let's first understand what is pipeline. So it is a technique of decomposing a sequential process into sub operations. So when a process is executing and if it is a large process, so it will take much time. So we will decompose means we will divide that sequential process into sub operations with each sub-process being executed in a special dedicated segment. So when we divide, so we will make sure that each sub-process will execute in a different segment. That is dedicated segment. It means it is different. It is that means many different segments will there, and it will execute in a different segments, and that will operates concurrently with all other segment. Means it will run parallelly with each other segments. So example as we take, so here a into b plus c. So let make sure that if we want to derive this for I is equal to 1 to 5. Okay, so it will take much more time if we do like a into b, then we will do that result plus c. So we will divide it into segments. So first we will take a value into r1, b value into r2. Okay, so we will do that both in one segment. Then we will take r3, means we will multiply r1 and r2 into r3 and taking the value of c into r4. It will done in the second. It will done in the second segment. So and the third step will be r3 plus r4. So it will store in the r5. So as we can see, segment 1 addition, segment 1, sorry, taking the values, segment 2 addition and taking the C value, and segment 3 will be, so it will run parallelly concurrently. Okay. So pipeline is applicable in arithmetic pipeline, and the second one is instruction pipeline. So arithmetic pipeline will, it means divide arithmetic operation in sub operation. It will divide the operation like addition, subtraction, that. Okay. So arithmetic pipeline. So it is mostly used in high speed computer. So it is used to implement floating point multiplication, addition, but of fixed numbers and similar computation encountering scientific problem. So to understand the concept of arithmetic pipeline more convenient way, let us consider an example of pipeline for floating point addition. Okay, so the input of the floating point, so as we can say, a is equal, x is equal to a into 2 raised to power a. So capital A, sorry, small a and b are exponents. So as we can say, 0.904 into 10 raised to 3 and 0.8200 into 10 raised to 2. So a and b are the two fractions, and small a and b are the exponents. So the combined operation of floating point addition and subtraction is divided into four segments. Each segment contains the corresponding sub operation to be performed in the given pipeline. So here it will execute in four steps. So compare the exponents, align the matrices, add or subtract, normalize. So let us see the sub flow chart. So when the matrices will be there, so capital A and B. Okay, so first see the A and B exponent. So we will first compare the exponent by subtraction. We will take the difference and then it will be going to the align matrices. So when it will be align the matrices, it will add or subtract the matrices and then it will be stored in R. So this will be performed in segment 1, 2, 3, and then it will normalize the result and it will adjust the exponent. This exponent that come, so it will exhaust the adjust exponent, then it will be to the R. Okay. So first step is compare exponent by subtraction. So we will see which has the greater exponent. So here in this example, 3 is the greater exponent. So we will, and the 2 will be the smaller. So we will take the difference, 3 minus 2 equal to 1. Okay, so it determines that the smaller exponent value must be shifted to the right. How many times? So the answer that comes, that is 1. So it has to be shifted right to one time. Okay, so the matrices second is align the matrices. So the matrices associated with smaller exponent is shifted according to the difference. So we get the difference one, so smaller is the y. So we shift the one right to, so it will become 10 raised to 3. So add the matrices. So the two matrices are added in the segment 3. So x plus 5. So when we do addition, then we will get 1.0324 into 10 to the power 3. Second, normalize the result. As we get in 1.32 to the power 3. So we have to normalize it. So we will take into 0 point format. So when we take 0 point format, so it will be 0.1324 into 10 to the power 4. So these are the 4 steps we discuss in arithmetic pipeline. Thank you.